Alright, so this video is going to be part one of integral problems with parametric equations, alright? So we have our problem on the board here. We need to find the area enclosed by x equals a cosine theta, y equals b sine theta on the interval 0 to 2 pi. Okay, so we know how to integrate parametric equations, right? We use this substitution rule equation right here. So we need to find f prime of t, okay? That's one thing that we need to find. Remember that x is a function of t, right? And then y is g of t. Okay, so to find f prime of t, we just integrate a cosine, we take the derivative of a cosine theta. So that's going to be, well, negative a sine theta. And of course, g of t, right, that's just what y is equal to, so g of t is b sine theta. Alright, so now we know what we're plugging in. Now, the last thing that we need to find before we plug into our integral here, we need to find our bounds, alpha and beta. Now, our interval is from 0 to 2 pi. Okay, so maybe those would be our bounds, but we should also look at our parametric equations beforehand. Okay, and as you can see, these are the parametric equations for an ellipse. Okay, because if you just had x equal to cosine theta and y equals sine theta, we know that those are the parametric equations for a circle. Okay, but now that you have different amplitudes in front, right, a and b, now you get an ellipse. Okay, so an ellipse is going to look something like this. Somewhat decent drawing, I guess. Alright, and an ellipse, okay, the area in the first quadrant of an ellipse is just the total area divided by 4. Okay, so we could honestly just integrate from 0 to pi over 2 and then multiply by 4. Okay, but there's a problem with that. If we integrate from 0 to pi over 2, okay, just don't even worry about, I guess, the rest of this now. Just focus on this, the first quadrant here. Okay, if we integrate from 0 to pi over 2, we're integrating in the left direction, right? We're integrating backwards, I guess you could say. And that means we're going to get a negative answer, right? So if we want to get the positive answer, what we do is we integrate from pi over 2 to 0, so we're actually going in the positive direction, right? And that you can remember back from your integral properties in Calc 1. If you were to integrate something from 0 to 3, that would be the same thing as the negative integral from 3 to 0. Okay, so that's kind of what we're talking about here. So now we can plug into this integral here. We're going to get the integral from pi over 2 to 0 of f prime t, which is negative a sine theta, times g of t, which is b sine theta. And we have d theta on the end. Alright, so we can take out this negative a, we can take out this b. Alright, so we get a negative ab on the outside. One thing that I forgot, by the way, we got to put that 4 out in front. Okay, so we get negative 4ab, and then we have the integral from pi over 2 to 0 of sine squared theta, d theta. Alright, that's a close call with that 4 there. Alright, so this negative means we can just switch the bounds back on the integral here. So we'll end up with 4ab, the integral from 0 to pi over 2, of, we can use our half angle identity here, 1 minus cosine of 2 theta all over 2 d theta. And if you want, we can bring this over 2 out, so we get 2ab, the integral from 0 to pi over 2 of 1 minus cosine of 2 theta d theta. Okay, integrating that here, we're going to get 2ab times theta minus sine of 2 theta over 2, which is going to be evaluated from 0 to pi over 2. Alright, and just doing that evaluation, we're going to get 2ab times, well, when we plug in a pi over 2 here, it's just, of course, going to be pi over 2. And if we plug in a pi over 2 into theta and sine of 2 theta over 2, well, we're going to get sine of pi. And what's sine of pi? Well, that's 0. So you're also going to get a 0 here. And when you plug in 0 here, okay, that's just going to be 0 minus sine of 2 times 0. That's just going to be 0. Okay, so altogether you get 2ab times pi over 2, which is just pi ab. Alright, and at some point in your math career, you've probably learned that this is the area of an ellipse, right? That's how you find the area of an ellipse. So it's kind of cool to see that, but now with parametric equations. Alright, so that's going to do it for this video. So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for parametric and polar, the explanation video for parametric integrals, and the next video in the series. See you soon.